Hello everyone, welcome back to my channel. I am Ranjit GS, a CSC student from Venkateswara College of Engineering, Bengaluru, and currently I am studying in third semester. And in this video, I am going to discuss a topic related to OOPS in Java, that is Object-Oriented Programming in Java, and the subject code is VCS 306A. And the topic is multi-threaded programming in Java. Before going into the topic, first we should know what is a thread. A thread is a simple unit of CPU utilization which contains a thread ID, program counter, a stack, and a set of registers. Let's see the introduction to multi-threaded programming in Java. Multi-threaded programming allows for the concurrent execution of multiple threads within a single program. Threads are lightweight unit of execution that share the same memory space. Java provides built-in support for multi-threaded programming through the java.lang.thread class. Threads share the same memory space and resource but execute independently. Benefits of multi-threaded programming. Improved performance. Multi-threads can execute tasks simultaneously, making efficient use of system resources. Responsiveness. Background tasks can run concurrently with user interactions, preventing the applications from becoming unresponsive. Modularity. Threads can be used to encapsulate different functionalities, enhancing code organization and maintainability. Web server. For example, single-threaded web server. A client might have to wait for its request to be serviced. Multi-process web server. Used before threads become popular. Much overhead in creating a new process. Multi-threaded web server. Less overhead in thread creation, concurrent services to multiple clients. Many OS kernels are now multi-threaded. Several threads operate in the kernel. Each thread performs a specific task such as managing devices or interrupt handling. Now let us see the creating and managing threads. To create a thread, we can extend the thread class or implement the runnable interface in Java. The start method is used to start the execution of the thread. The join method can be used to wait for a thread to finish its execution before proceeding. Thread synchronization. Synchronization is used to prevent multiple threads from accessing shared resources simultaneously, ensuring data consistency. The synchronized keyword can be used to mark methods or block of code as synchronized. Locks such as reinterlock and synchronized blocks can be used to manage thread synchronization. Thread intercommunication. Threads can communicate with each other using mechanisms like wait, notify, and notify all. The wait method causes a thread to wait until another thread notifies it. The notify method wakes up a single waiting thread while notifying all wakes up all the threads. Thread priority. Threads have priorities where higher priority threads get more CPU time. Use set priority of int priority to set thread priority. Deadlock prevention. Deadlock occurs when two or more threads wait indefinitely for each other. Avoid circular dependencies and ensure proper resource allocation. Now let us see the thread life cycle. The thread life cycle consists of several states: new, runnable, blocked, waiting, timed, waiting, and terminated. A thread transition between these states based on its execution and synchronization requirements. Understanding the thread lifecycle is essential for effective thread management. Now let us see the thread pools. Thread pools manage a pool of worker threads, reusing them for executing tasks. They provide efficient resource management and reduce the overhead of thread creation. The executor framework in Java provides APIs, that is application program interfaces, for creating and managing thread pools. Thread safety and concurrent collections. Thread safety ensures the concurrent access to shared data loss does not result in data corruption or inconsistency. Concurrent collections such as concurrent hash map and copy on write array list provide thread-safe alternatives to their non-concurrent counterparts. Proper usage of thread-safe collections helps prevent data races and other concurrency issues. Thread scheduling and priorities. Thread scheduling determines the order in which threads are executed by the operating system. Thread priorities can be set to influence the order of execution, but they are only hints and not guarantees. Care should be taken when relying on threads priorities, as they can vary across different platforms. Best practices of multi-threaded programming. Use thread pooling instead of creating and managing individual threads. Always handle exception in threads to prevent unexpected termination and resource leaks. Test and debug multi-threaded code thoroughly. As concurrency